Alright class, today we are going to be looking at 5.3 and 5.4. There's a lot of new vocabulary in these two sections, so I highly recommend maybe at the end going through making a cheat sheet with all of the vocab words and the definitions, or maybe making some flashcards, because these will be some new words that you have never seen or heard of in the context that we're about to go over. Alright, so first we are looking at angle bisectors of triangles. So the bisectors part should sound familiar. We know that means that something is cutting something else into two congruent pieces. So in this case, a ray that divides an angle into two congruent adjacent angles. The distance from a point on the line is the length of the perpendicular segment from the point to the line. Okay, so basically that means if we have a point, so in this diagram, we have the point S that is on the angle bisector. We know it's an angle bisector because if you look down here at this angle, they're two equal pieces. So this point S is going to be the distance SQ to the ray PQ. So your distance has to be perpendicular to the outside of the angle. Okay? So example, let's write this out. It's going to look fancy. Ray PS is the bisector of angle QPR and the distance from S to ray PQ is SQ, with SQ being perpendicular to PQ. Okay, so big thing here, your distance must be perpendicular to the side of the angle. Alright? Now we have an angle bisector theorem. Okay? If a point is on the bisector of an angle, then it is equidistant. That's the word we learned last time. Equidistant from the two sides of the angle. Remember, equidistant is just equal distance. Okay, so we have a point, this time we've got the point D that is on the bisector of the angle. So this is our bisector. We know that because we can look at our two angles down at the bottom. Since D is on that bisector, it is going to be the same distance to both sides of my angle. So I know my two sides, we have AB, ray AB, and ray AC. Since those two angles down here are equal, that means that D is going to be equidistant to both sides of the angle. So we would know that BD is the same length as DC. Okay, so writing all of this properly, we would say if ray AD bisects angle BAC and segment DB is perpendicular to AB, and DC is perpendicular to ray AC. There's supposed to be ray AB. Then BD will be congruent to, or you can say equal to, DC. So if you have a point on that bisector, it's going to be equidistant to both the sides of your angle. Okay, in the converse, remember converse, you flip your P and your Q. So this was if P then Q. Converse, we're going to say if Q then P. So we're just switching what we just said. Here we would say if a point is in the interior, or that means inside, of an angle and is equidistant from their sides of the angle, then it lies on the bisector of the angle. So here, going in reverse, if DB is perpendicular to ray AB and DC is perpendicular to AC and DB equals DC, then AD, ray AD, bisects angle VAC. My handwriting looks a little shaky today. I'm not sure why that's happening. Hopefully y'all can read this. These notes will also be posted as a hard copy in my Google Classroom. So if you can't read this, I do have a filled out version of my handwritten notes on paper that might be a little bit easier to read if you also wanted to look at that version. Okay. So those are our first three new things. Let's look at some practice. All right. The things we are going to be looking for. We want to look for angle bisectors. We want to see if our point on the possible angle bisector is equidistant to the two sides of our angle. We also want to check and see if those distances are perpendicular, because they must be perpendicular to be that distance. Okay, so number one, I see that we're looking for this angle. All right. We need to determine if FJ is a bisector, angle bisector. So I'm just going to write that question. You don't have to, but this is what we're thinking. Is FJ an angle bisector? So we need to know what would make it an angle bisector. Well, if ray FJ was an angle bisector, it would be the same distance, point J would be the same distance to the two edges of the angle. Okay, so from J to G is 7 and it's perpendicular. J to H is also 7 and perpendicular. Now I know that yes, FJ is an angle bisector, which means this angle down here is being split into two equal pieces, so X will equal 42 degrees. Simple as that. No, didn't even have to add or subtract or multiply or anything. Just looked at your diagram. Okay? 2 looks like it's going to be the opposite of what we just did. So now I see that my ray is an angle bisector because 27 is congruent to 27. So that means this point, we'll call it A, it's not labeled, that A will be equidistant to the two edges of our angle. So since A, we'll label this to B, is 15, I know that A, so we'll say C, is also going to be 15. So X equals 15. Last one, 3. Again, is that ray an angle bisector? Okay, how do we know these things? You either look at the angle or you're going to look at the distance from the point to the edge of your angle. I see the tick marks, so yes, that will be an angle bisector. Therefore, we know that these two angles are equal. 3x plus 5 equals 4x minus 6. All right, x equals 11. Answer. Okay. And then here's a little thought-provoking question. Do you have enough information to conclude that ray QS bisects angle PQR? Explain. Okay, so is it true that QS cannot be an angle bisector? Why or why not? Think about that for a second. Think about what we would need to know. So there should be 2 things you're thinking, or maybe 3. So do we have congruent angles? Do we have the same distances between that point and the edge of the angle? So I'm just say the distance. And then 3, is it perpendicular? Is that distance perpendicular? So 2 and 3 kind of go together, and then 1 is by itself. So you can't assume anything. So I cannot assume that these 2 angles right here and right here are equal. So 1 does not count. Now we need to look at the distance. Okay, I do see from SR to SP, those are congruent. That's great. Are those 2 pieces perpendicular? So do we know that PS is perpendicular, and do we know that SR is perpendicular? That's no. Okay, so we would need to know that SP was perpendicular to QP, right, QP. And we would need to know that SR was perpendicular to QR. If we were told that, then we would know that QS was a bisector. All right. Okay, now we have something called the concurrency of an angle bisector of a triangle. So basically concurrency, that's just going to be where a bunch of lines or segments come together and form a point. Okay, so for an angle bisector, the angle bisectors of a triangle intersect at a point. So that means intersecting at a point, that means that they are concurrent. So the angle bisectors of a triangle intersect at a point that is equidistant. We love that word. Basically equidistant from the sides of the triangle. Okay. So let's look at our example. We're looking at angle bisectors. So sometimes it can be great to identify the angle bisectors. So here we would need BP, AP, and CP. Those are all of your angle bisectors. So we will say if AP, comma, BP, comma, are angle bisectors, it says the angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. Because these three are angle bisectors, then we know that they are all the same distance. Remember, distance is perpendicular to the side. So now look at all three of your perpendicular pieces. PD, PE, PF. So we know that DP will be congruent to EP, which will be congruent to FP. Okay, you can put little tick marks on all three of those places. So angle bisectors, that point, will be equidistant to all three sides. So we would call this a point of concurrency. Whenever you have your angle bisectors, their point of concurrency is called the incenter. Okay, that is actually going to be a vocab word that we did not put in the notes, but incenter is where your three angle bisectors intersect. Make a flashcard for that. We need to know that incenter and angle bisectors go together. Okay, so here we've got some practice. We'll do this practice together, and then I'll just leave some, you should probably pause the video to you try it. So we want to answer these questions. Point D is the incenter of triangle XYZ. So we know, since we're told that D is the incenter, I know that XD, YD, and ZD are all angle bisectors, right? But we're not looking at angles here. It says to find DB. This is a segment length, okay? So it's very important, I think, I always like to highlight what we're looking for. So here's DB. I notice that that is the distance between my incenter and the edge of the triangle. We just learned that the incenter is equidistant to all of the sides. So DB, DA, and DC will all be the same length. Oh wow, I see that DC is 9, so I know that DB will equal 9. Okay. 2 might be a little bit more intense. There are more things labeled. We're looking for other things. So here we have segment KZ, segment LZ, and segment MZ are perpendicular bisectors of triangle GHJ. Okay, notice this doesn't mention incenter, not mentioning angles. We're looking at perpendicular bisectors. So I need to be focusing on my sides of my triangle. All right. So first, let's start off with finding HZ. So H to Z. Okay. So looking around, I know that it's not an incenter. We don't know that's an angle bisector. We were just told that KZ, LZ, and MZ, those are actually perpendicular bisectors. So if it helps, you can do the perpendicular symbol, and then they're bisecting our segments. So GM, MJ are equal, KH, KG, HL, LJ. So you go around, mark all those congruent pieces. Okay, if we go back to those perpendicular bisector notes, that's actually from last class, or maybe 2 class periods ago. We know that if you have a point that is on the perpendicular bisector, then that point is going to be equidistant to the 2 endpoints of your segment. Okay, so let's think about that. So here, we're looking at H to Z. That point Z is on the perpendicular bisector. That is KZ. So KZ is bisecting HG. So I know that this point, Z, is the same distance to G as it is to H, since it is on the perpendicular bisector. So ZG is 19.9. That means that HZ will also be 19.9. Okay, so go back and look at those perpendicular bisectors. If that is confusing to you, that would be on page 5, the perpendicular bisector theorem. Okay, I'll make a side note there. Page 5 in your notes. All right. Next, we need to find GM. So we are looking for GM. Okay, so let's highlight GM. Oh, that'll be easy. We know that M will be the perpendicular bisector, so it's bisecting GJ. So GM will also be, let's not use yellow, sorry, 14.5. Looking at GK, again, another simple one. That's going to be half of that entire segment. So if we look at the other side, we can see that it's 18.6. And then last but not least, JZ, not the wrapper, just the segment. I hope y'all laughed. That was funny. Okay, JZ, again, this point Z is on the perpendicular bisector of ZM. So I know that Z is the equidistant to J as it is to G. ZG is 19.9, so ZJ will also be 19.9. A and D go along with each other. Those are the same type of problems. Okay, go ahead, pause this video and work through those. You try it on your own. I will just write the answers down in a second, and then you can check your work. If you need to see all of the work written out, again, that can be found in the notes that I've handwritten in the Google Classroom. So go ahead, pause this, work on 1 through 6, and then check your answers. Okay, so for number 1, x will equal 4. Number 2, x equals 5. Number 3, x equals 8. And number 4, we've got 5.64, 5.47, 3.95, and 5.64. And then our last one in 6, we are looking for the distance from x to PQ. That is going to be 19.2. Okay, so hopefully you didn't have too much trouble with those. Again, in the filled out notes, in the Google Classroom, you can see the equations that I wrote for some of those problems. Moving on to 14.4. This is use medians and altitudes. Okay, so you might have heard of these words before, median and altitude, but I'm pretty certain that these will probably be new definitions and how we're using them. Okay, so first, using medians. We need to know what the median is. So the median is going to be a segment from a vertex to the midpoint of the opposite side. Okay, so here, let's change this to A and B, not C and D, that's silly. So A and B, it says the 3 medians of a triangle are concurrent. So that just means that they're going to intersect at one point. The point of concurrency is called the centroid. Okay, so centroid goes with median. Okay, our example here of a centroid is going to be point P. That is your centroid. Looking at this diagram, let's think about what the three medians are. So we're going from a vertex to the opposite side. So if we choose B, the opposite side takes us to F. Notice that F is in the middle of AC, so that is your median. It goes from a vertex to the middle. So BF will be 1 if we chose point A. AE is a median. Lastly, C to D. I don't know why that got just so thick. C to D would be our last one. And then in the middle, point P, that is your centroid where all three of those come together. Remember, in-center is with altitude. Centroid is with your median. Okay. The concurrency of the medians is going to have a special property. Okay, so we will see that the concurrency of medians of a triangle is going to have special properties. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so 2/3, that's a fraction. So each segment of these medians can be divided into these different parts. So we think about the segment BF. Okay, so the medians of the triangle intersect at a point. So this point right here is 2/3 of the whole. Okay, so we think about this, looking at all these other pieces, we can write some equations. AP equals 2/3 AE. So actually, we should look at that one first. If you look at this, AP, my pen's not working now. AP is 2/3 of this entire section. So let's think about what does that make PE. If AP is 2/3, PE will be 1/3. So notice all of these segments will be split up into 2/3 and 1/3. Okay. You could also think of this. We know 2/3 is 2 times 1/3, right? So you also know that AP is going to equal 2 times PE. Okay. So if you know the length of PE, just multiply it by 2 to get AP, because that would be 2/3. 1/3 times 2 is 2/3. Okay. So next we've got BP. That will be 2/3 of BF. Or we could say that BP equals 2 times PF. And then last but not least, CP. That'll be 2/3 CD. Or CP equals 2 times CD. Okay, and that is our information that we need to know about the centroid and its relationship. Okay, so let's get some practice here. Okay, so number 1, it says that Q is going to be the centroid. That means that all of these segments are going to be medians. But we want to find QW and SW. So 2 things we're looking for there. First, notice that SQ is 8. We know that 8 is 2/3 of that entire segment. So something I like to do is divide a segment into 3. We know that all 3 of these pieces must be equal. So the top is 8. This will be 4, 4, 4. So I divided the 8 by 2 to split that up into 2 equal pieces. And then I know that's 2/3, so all 3 must be 4. So QW will equal 4, and then SW will equal 4 plus 4 plus 4, 12. So if you're ever given that 2/3 section, just divide it by 2, and that gives you each third value. Okay? We were told that G is our centroid, so that means These are all medians, so you could also always go in and draw the tick marks around the edges. We're looking for a couple of things. First, we want FC. FC is where the sides go into It's going to be 12 because the other half of that side is 12. Then we want BF. Okay, so remember 6, that's the 2/3, so that can be broken up into 3, 3, 3. So BF 3, 6. It's going to be 9. Then we have A to G. Okay, so I kind of got so messy I already can't see that. A to G. It told us that AE is 15. So the whole thing is 15. If I break that up into 3, then I know it's going to be 5, 5, 5. So A to G will be 10. And then the last one we're looking at is GE. So GE, we just wrote that down. It was 5. Okay, let's go ahead and pause this video and y'all do number 3 on your own. See if you can figure that one out. Do your best control, and we're finding the value of x. Pause it. I'll go ahead and write out the answers, and you can look at the hard copy in Google Classroom if you need to see my work. Okay, going back, x equals 5 halves. You could also write 2.5 if you wanted. B x equals 9. C x equals 4. Alright. So centroid is with a median, in center, altitude, and last but not least, we have the altitude. What did I said in center. In center is not altitude. I'm not sure what I just said. Sorry, guys. In center is with our angle bisectors. We're about to look at altitude. I spoke too soon. Yes. Forgive me. So let's go ahead and make this shortcut. So in center, angle bisectors, centroid are for, what did we just do? Medians. Lastly, we have altitude. Altitudes are going to be with our orthocenters. But honestly, altitudes don't have any special properties. We're not going to see any cool relationships. An altitude is just the perpendicular segment. We will write out the word perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. So your altitude can be inside or outside of your triangle. For some examples, we've got QS, perpendicular to PR. QS is the altitude. So let's label that an S. For example. Or here, S, for example. Notice in the first one, our altitude is inside. The second one, our altitude is outside of the triangle. Okay. The lines containing the altitudes of a triangle are concurrent, so again, they will all meet in the same place. And like I stated earlier, your point of concurrency is called the orthocenter for your altitudes. An example, the lines containing AF, CE, and BD meet at G. Okay, so notice our triangles ABC. All those altitudes meet outside. That's still our orthocenter. Alright. Okay, looking at number 1 of this practice, So always look at your triangles and determine what you have. Do you have altitudes? Do you have medians? Do you have angle bisectors? Do you have perpendicular bisectors? You have to be able to identify these on your homework and tests and quizzes or anything that we might give you on the SOL. It might not always tell you what you're given. Okay, so looking at number 1, do we have the altitudes of this triangle? Okay, hopefully you answered no, because remember the altitude is going to be from a vertex to the opposite side and it's perpendicular. So I would only see one altitude right here, right? All the other ones don't even connect to the other side. These actually are not going to be altitudes. We're going to be looking at angle bisectors. So notice all of the angles are split into 2 equal pieces. So what do we know about angle bisectors? Well, I know that they form that point in the middle, going back. Remember that point is called the incenter. And we know that the incenter is equidistant to every side of our triangle. So this equation we should get from here is 2x plus 2 equals x plus 7. We solve for x, and we see that x equals 5. Okay? Number 2, we're just going to name the altitudes. So you want to find a vertex to the opposite side where it's perpendicular. AX, vertex, opposite side, perpendicular, BY, and then lastly, CZ. Those are your 3 altitudes. Okay, lastly, we've got a small section of you try it. I encourage you to go ahead and pause this video and do these on your own. Check to see, are you looking at altitudes, medians, angle bisectors, perpendicular bisectors? Do you have the incenter? Do you have the orthocenter? Do you have the centroid? And determine what can you determine from those different definitions and words. Okay, so pause this, I'll write up my answers, and then you can check your answers once you're done. So I got BW equals 29, BW equals 19, BE equals 57. Number 2, JQ, 28. Number 3, GV equals 16.4, VB is 8.2, VC 5.8, EC 17.4. And then lastly, GY is 42.2, GP is 46, GJ 57.6, PH 46. So check those answers. There wasn't much math with any of those. Some of them you would have to do the 2/3 if you have the centroid, which was with your median. Okay? So quickly, cheat sheet if you want something to reference, or if you want to make your own little sheet study or flashcard. I think these would be some of the important words. Okay. Perpendicular bisectors. First. The second one, I would recommend making a flashcard for angle bisector. We need to know that your angle bisectors come together and form an incenter. You need to know the information about the incenter, how it's equidistant to the different sides. Then we would need to know about our median. The point of concurrency for all your medians is going to be the centroid. Then we have our altitude with its point of concurrency being the orthocenter. Okay, so that is 1, 2, 3, 4, 5, 6, 7 new words you need to know what they look like. You need to be able to identify them, and you need to be able to determine the different properties and what each one of those things means. B-Day, if you're watching this, your homework. You've got 2 homework sheets due Monday. If you are confused by anything, just do your best. We will go over all of this information Monday, but I need to see some effort for you to be able to get credit. Anybody that's listening to this, hopefully you understood this material. Always go back and ask your questions, whether that's before school, after school, during class, during your resource block. Make sure that you're clarifying with us and really understanding the material. I hope everybody's having a great Thanksgiving break, and we look forward to seeing you afterwards.